Hi, the preface to this video shows my polyrhythmic pattern generator in operation. The bulk of the film will explain in more detail how it works, and an addendum at the end will show how to set up the link between the TouchOS screen on my iPad here and SonicPi, which is doing all the hard work. So the program is running. Let's just load in a pattern and play it, so you can see the sort of thing which happens. Let's make it a bit faster. Let's perhaps change the samples which are generating it. Let's manually change the pattern by adding in some other components. Be a bit quieter. Go to a different pattern again. Let's load in another pre-saved one. This is a pattern of 4 against 6. For every 4 in channel 4, there are 6 beats in channel 6, and so they start off in sync and get out of sync, and you get this nice pattern. And we can also adjust their positions in the stereo spectrum if we want, to separate out the bits and hear what's happening, or indeed play them with different samples, which makes it clearer what's happening, and then combine them together again to hear the final pattern. Here's another one. This one's 6 against 8. We can alter the relative volumes of these, which can in fact give a completely different effect to them. It's exactly the same beats, but they sound completely different when you do that as to when you do that. And all we're doing is altering the relative volumes of them. There's another one. Slightly more complex one. Try it on a different sample. There's 3 different tom-tom samples here, and there's some of the elec samples at the beginning. You want a more electronic sound. And of course you could set up the program using a different list of samples instead of the list which is here, which is the one that we're currently using. There's no reason why they shouldn't be changed though to whatever you want to use. Different sample. Load that one in. If we want to make up a new one from scratch, at the present sample position 10 is blank here, so let's put something in there. Put some volume on. Let's try some 8 and some 4 and a bit of 6 as well. Maybe a bit of 2 as well. And let's perhaps just change around a bit how these are, and maybe let's put the 8s, put them all on a different pattern there, apart from 8. Down to that one. Oops, it's 8, it's not 9, that one. Yep. And we will now say enable save and save that. So if we go to a different pattern, that's pattern number 4, we go back to pattern number 10, we can load that in, and we get back to where we were. If we want to wipe that out, we can simply zero all the settings which are here. Should zero them all, and zero the pan settings, and we'll set that back to the first one, and then we can save that again in that slot so that it's now basically vacant again. There's a second pattern bank, so it gives you another 10 different samples. For example, number 10 in that one has got something in it, and we can hear that now. We can adjust the tempo, and these make them faster or slower, and we can start or stop and synchronize to the start of the cycle. and finally we can use the master volume to fade them out. Thank you for watching this section. The second section goes in more detail to how this is all set up. Hi, and welcome to a video which shows the use of a polyrhythmic pattern generator, which I developed in SonicPi 3, which uses internal samples from SonicPi, from the various drum samples which are present, to build up rhythms whereby you've got sequences of drums playing at different rates superimposed upon each other, ending up with some fairly complex rhythms. So, for example, you might have one set of drums which are playing 4 beats per bar, and playing at the same time another set of drums which are playing 3 beats per bar in the same time space, so that the two rhythms are sort of fighting against each other. I got the idea for this when I was researching with Google on polyrhythmic generators, and I came across a website which is here. Now this works by having 10 sliders here, each one of which produces a separate drum pattern. If I slide my first one up, you'll hear that. That's going at a fairly slow rate. We slide the second one up, it's going at twice the rate. And so on until we get to the last one, it's going at 10 times the rate. And so by building up different sequences of these, you end up with the final drum pattern. Now this is a commercial venture, and I'm not using any of the code which is incorporated with this. What I've written is entirely original from that point of view. All I'm using is the mechanism of producing 10 different drum patterns, which is simply by having 10 volume controls and controlling sources like this. Now if we minimize that now and switch over to SonicPi, you'll see that I'm using as the input to this program Touch OSC, and we've got a picture of my tablet here, which has got the similar set of sliders that we saw previously here. Sorry, I'm trying to move it there. I need to move it on the actual pad, and you can see that moving. And you can see that as I move these sliders up and down, that there are some OSC messages being received by SonicPi, and the pink at the bottom right of the screen there, according to these as they move along. So let's have a look at this in operation. That's about the only similarity with the other set. And what I've got in the program, if I switch to this just briefly, is a series of 10 different live loops, each one of which is controlling the drum pattern for a particular rate, and those rates are given by these variables T1 up to T10, and you can see that if the interval between drum beats for the first channel is 1, the interval for the second channel is 1/2, so in other words, it's going to be half the time duration between them, and therefore twice as many per second. And for the next one, it's 1/3, 1/4, up to 1/10. And the remainder of the program is largely consisting of small live loops, each one of which is looking at some OSC messages which are coming in from the Touch OSC screen when I move something on it, and these cause events in each of the relevant live loops, and the information can be extracted from there and used to control the various parameters of these live loops which are playing. And each one has the following parameters to it. First of all, there is the sample which is being used. The second one is the sorry, the next one there, T1, is the factor which is going to give the time. Then there is one which is going to give the pan position, and there is one which is going to give the volume setting. I can't remember for a moment what the second one was, so let me look at the definition of that, which will be a bit further up here. Here we are. The second one yes, in order to get everything synchronized together, what we have to do is to play each drum sample a certain number of times. So for the one which has got one drum beat in the overall period, we only need to play this once, and we have a little loop here which is going to just go around one times for the first one. In order to fit the next drum beat in, which is going to go at double the rate, so the time interval between drum beats is half, we need to play that one twice to occupy the same overall period of time. And for the one which has got 3 drum beats in the time interval, we need to play 3 of those to occupy the same overall time that one drum beat occupies for the single loop. I think it's easier to look at this and we can actually see this in operation. So if we come back here, I'm going to first of all make a SonicPi screen a little bit smaller just to start with, so that you can see the effect on the screen when I start the program running, which I'm going to do now by doing Command R. I'm working off a Mac at the moment, and you can see that it initializes the screen there. It sets all the volumes to 0. As the master volume and overall volume, that's also at 0. Pan settings at 0. And the slightly lilac-coloured section here that says component samples is controlling the sample each one of those channels. And here, unlike in the original website I showed you a minute ago, I can actually allocate different samples to each of the individual components. This is quite useful when you want to orally hear how we're building up the completed pattern. So let's start this by turning up the master volume, and I'm first of all going to put the first channel alone on, and we're going to start this playing by pressing the start-stop button here. And there we go. That noise you can hear, that sort of tweak, is the sample it's using, and it's a very slow beat because we have to be able to fit 10 of the 10th channel beats in every time we get one of these. Let me first of all show you that we can change the synth for this. There's a different one. Sorry, the sample, a different one. And then the last 3 are all tom-tom. That one. That one. And that one. Now I'm going to leave this back here so that it's very distinctive, because I'm going at the same time to bring up the second channel at half volume, and we'll move it over to that. And you can hear very clearly there are 2 drum beats of the second channel for every one of the first. We can perhaps make that even clearer by adjusting the pan positions. So for the first hit, they both coincide. For the second one, channel 2 is there by itself. Let's go on to the third one. Take that out. And we'll move that third one onto there. In fact, let's just, here's a way of globally setting them. I'll set them all to the final stage and then move the first one back. Now we'll put the third one over on the right hand side. 3 of the drum beats on the third channel for each one on the first channel. Let's go to the fourth one. 4 for each one. Fifth one. 1, 2, 3, 4, 5. Sixth one. Seventh one. Eighth one. Ninth one. 10th one. And we can zero the whole lot by pressing that button there. So you can see how we can look at the individual components, but where it gets very interesting, and the idea of the polyrhythm is to have more than one of these running at once. Well, we have had the first one and one of the others, but we get much more intricate patterns if we look at some other combinations. So let's, for example, take 2 and 3 together. Oh, we've turned the volume down there, that's what it was. There we are. And we get that pattern. And if we separate them out like this, you can hear them in different parts of the spectrum, and if we perhaps put the second one on a different you can hear very clearly the 2 beats and the 3 beats, and they coincide and then they separate, and 6 beats later they get 6 bashes later they correspond again. So to make things easier, because we've got quite a lot of things to adjust here, I've added a section over on the right hand side that says pattern select, pattern bank, and load and save pattern and enable pattern, which enables you to save settings and to recall them. There are actually 2 banks, 1 to 10 here, and if I put that onto the second bank, another 1 to 10, giving 20 possible setups which we can save. So let's recall the first one in the first bank like this. And this has got a bit of channel 2, a bit more channel 5, and a smaller bit of channel 10. And again, we can just set them all. I only actually moved the selector for the sample over the channels which are playing, but if we put them all there by pressing that, won't we hear any difference? But now at least we could come and change 1 or 2 of these. Let's take channel 5 and put it down there. And let's take channel 2 and put it down there. And let's move them like this. In fact, channel 10, we'll just take it out for a minute. That's 2 and 5 together. A little bit of 10 added in. Here's our final pattern. If we make them all coincide in the stereo spectrum, we get that effect, and if we put them all on the same sample, we get that, or that, or that. That, or that. Now we can also, if we want, change the tempo. I've got 5 different tempo settings here. You can speed it up there, or even faster. Let's go back somewhere in the middle there. We'll leave that and go on to the second one. This has got 3 against 4. 3 beats per cycle against 4 beats per cycle. Next one has got 4 against 6. And we've actually got some pan settings on that. I'll just reset those. It's quite good, as I say, just so you can hear how the two parts add together. If you separate them, they come back together again. Next one. 6 against 8. And you can actually get quite different sounds by just adjusting the relative volumes of these. It sounds in some way quite different to having it like this. Oops, I put the middle one in as well. On to the next one. Next one. And so on. If we go on to the 10th one, there is nothing hopefully recorded on that at the moment, just to show you how the save works. Now, because saving is quite a drastic thing to do, if you just brush the save pattern, it just gives a beep produced by SonicPi, but it doesn't actually save because we want to arm the save pattern first. Let's just put something in to save, like 4 and 6, and a bit of volume on it, and maybe change it to, let's go on the first sample like that. Supposing we like that, we want to save it, we simply enable save and press that, and it beeped because I didn't do it quick enough, because that only lasts for about a second, then turns off again. We have to have that active save. That's now saved. If we go back to 6 and load something else in, we can then go back to 7, and there's the pattern that we've just done. If we want to obliterate that, we can just go to 0 all, enable save, and save over the top of it. If we go back to, say, 7, put that on, then back to 10, there's nothing in it. If we switch to the second bank, then we've got another range here. Now that's got a whole range of all 10 samples in it. This one, that's just got 10. It's got 9 and 10. They start off more or less together, then get out of sync, and then come back again every cycle. Next one. It's got 1 in by itself. So you can see that it's great fun to play with this. It's quite responsive, and it works on a Pi 3 as well as on a Mac, and I don't see any reason why it shouldn't work under Windows as well. All you need to have is a tablet, or you could reduce this so that it get quite small and fiddly if you did it on a phone, because I've actually designed the size of it at the moment onto a tablet size screen, but it could be done smaller as well. So we'll just, one other thing about the start-stop is that this is synchronized so that it starts and stops at the end of each cycle. And in the same way, if you change something, it'll be picked up the next time the cycle comes round, and that way everything stays in step with each other. So we'll stop that, and thank you very much for watching, and I'll just stop this video. We just have a small addendum section on the end of the video on the polyrhythmic pattern generator, and that is to show just how the setup goes between the touch OSC on the iPad and SonicPi itself. If we come first of all to SonicPi, and I make the screen a bit bigger, and we then turn on the settings, you'll notice if you go to the I/O tab that it tells you on here the local IP address of the of SonicPi on the machine it's running from, and it tells me that it's running on 192.168.1134. If we go to the iPad and we press this little silver circle in the top right hand corner there, and then the OSC connections, we need to make this sure that this has got the right settings on it. First of all, you'll see that if I move this screen down a little bit, that we've got the same address there, 192.168.1134, as the host address given here, 192.168.11134, and that it's sending stuff to port 4559, which is the port that SonicPi is listening on. In the other directions, we need to send OSC messages back again to set the sliders. When, for example, we recall one of the stored programs, that is decoded, and it sends OSC messages back to move the sliders to the correct position to keep the touchscreen in sync with what's going on. And you'll notice that this tells me that the iPad has got a local IP address of 192.168.1.240, and if we come back to the program here, right at the top of it, there is a line which says use OSC 192.168.1.240, 9000. That's the address of the Touch OSC tablet, and 9000 is the port on which it's listening, and that corresponds with the 9000 there, the incoming port, and the local IP address 192.168.1.240. Once you set these up and we go back to the screen there, we can check obviously that we are sending stuff from the iPad back to SonicPi by simply moving any one of the sliders here, and we can see at the bottom the OSC messages which are coming in, which shows that the communication is working that way. And to see whether it's working the other way, you just need to do something programmatic in SonicPi, which is going to send signals back again. And the easiest way to see it's working is that when we actually run the program, if I come here and just stop it and then run it, if we go back to here, we can see that it's reset all the values here, and we can see it also if we want to load in one of the patterns, we could see that it's obviously altered the slider positions there when the load pattern has been received. Incidentally, because that will be new to some people, one other comment on the program is that I actually use a standard file handling here. We're using a file in JSON format, which is an easy format for storing information in a simple text file. And that's just the path of where it's going to be stored on my machine. And further down towards the bottom of the program, we have got a section which is going to write to the JSON file here. And we actually store the information that we want to be written, which is the array which is going to hold all the volumes, the array which is going to hold all the pan settings, and the array which is going to hold pointers to which of the samples to use for each of the different channels. Those three pieces of information are stored. I don't store the tempo. That's just set manually to what I want to do it. And so those are simply put into those into this hash here. So into vals :val v, we store the list v, which is going to have the different volume settings. Into the vals :val p, we store the pan settings, and to vals :val sam, we store the sample pointer array, which is going to store pointers to which sample to use. These are written out to the JSON file here, and there's a corresponding one which is going to read the information back again, and then it's going to set the values of the three different lists back to them. Though that's called pans to 0 and vols to 0 and sam number to 1, they were actually used in the initialization to 0 everything, but by sending a parameter 1 to it, I tell it instead to actually use these restored values instead. So that's how that all works out. There is a gist with the software on it, and there is a comment below it which tells you how to take the XML file, which is also there, and to load that into TouchOSC to produce this screen, which is used for the control purposes. So thanks for watching this extra little bit.